Well, happy Friday, everybody. I hope you guys are ready for your weekend. I know Mr. Stevens is definitely ready for his weekend. So make sure you guys are ready to go on Monday when you come to class. We have a short set of notes tonight. Hopefully it shouldn't take too long for you guys to get them done. And other than that, let's make sure we do our notes correctly, and let's try to everybody get them done. I want to see. Matter of fact, I will do this. If 90% of your class does your notes this weekend, I will give everybody 20 extra credit points. Okay? So hopefully that'll be a little bit of incentive that if you're not sure if somebody's going to do their notes, maybe hit them up, shoot them a text message, Snapchat, text, Facebook, Twitter, any of that stuff that you guys use. Send them a message. Get them to do the notes. Free 20 extra credit points for your class as a whole if 90% do the notes. Okay? So with that being said, let's get to work. So now I told you we're going to be doing solving systems, and this time it's going to be by elimination. Your objective is that students will be able to solve the systems using elimination with at least 80% accuracy on their 10-question assignment. So for the last set of problems, we ended up working on these, and we would solve one of them and use what we called substitution, and we would find our answers that way. Now we're going to do something that's called elimination. Okay? And the gist with elimination is that I want to add these two equations together. And I want it, when I do that, I want it so that it eliminates one of my variables. Okay? So when we start this, the first thing we have to do, hint, step one, we need to see if the coefficients for one of the variables are opposites. If they're not, we want to make them opposites. Okay? So when I look at the x's right now, I have negative 2x and I have negative x. Those are not opposites. Negative 2 and negative 1 are not opposites. So now I want to check the y's. I have positive 3 and I have negative 3. These are what we call opposite coefficients. Okay? One is positive, one is negative. When I add them together, they will give me 0. So because that's the case, I'm going to go ahead and I'm just going to add these two equations together. Now, your simplifying rules apply here. So you can only add like terms. So I have an x and I have an x here. These are what we call like terms, so I'm going to add them together. Negative 2x and negative 1x gives me negative 3x. Plus 3y minus 3y gives me plus 0. Equals negative 5 and negative 7 is negative 12. So now, when I've added those together, I am now left with one variable and one equation. I can solve this. So this is negative 3x equals negative 12. I need to divide by negative 3. And I get x equals 4. So this was the elimination part. Okay, we've used elimination. We have found one of our variables. Now we're going to actually use, so this is a combination of elimination and substitution. Okay, so now we're going to use substitution, and I'm going to take this and I'm going to plug it in. I'm actually going to choose to plug it in right there. So now I'm going to substitute. Split the screen here. Okay. So now I'm going to substitute, and I'm going to say negative x, which was 4, minus 3y equals negative 7. And again, I have one equation, I have one variable, I can solve this. So this is negative 4 minus 3y equals negative 7. I'm going to add 4 to both sides. I get negative 3y equals negative 3. Divide by negative 3, and I get y equals 1. Now, again, last thing I'm going to do, I'm going to check my answer. So I used the second equation when I found y. So I'm going to use the first equation now. So that's negative 2x plus 3y equals negative 5. And I'm going to plug in 4 for x and 1 for y. Negative 2 times 4 plus 3 times 1 equals negative 5. And we're going to check our work. Negative 2 times 4 is negative 8 plus 3 equals negative 5. That's negative 5 equals negative 5. My answer checks. So my answer then is 4, 1. And we're done. Okay, now this was a basic one. We were able to just add them right off the bat, so it made it a little bit easier. The next one, however, is going to get a little bit more difficult. So when I look at example number 2, I have negative 7x minus 2y equals 9. I have negative 8x minus 7y equals 15. And now I need to go through the same steps again. So again, one of the first things I need to do is I need to see, do I have coefficients that are opposites? So right now I have negative 7 and negative 8. Those are not opposites. Here I have negative 2 and I have negative 7. Those are also not opposites. Okay? So now I got to look at it and I got to say, okay, with this being the case, can I multiply one of these equations? Can I manipulate one of them so that I can make them opposites? Okay? So let's look. Can I multiply negative 7 by something to get the opposite of negative 8? No, you can't. Can I multiply negative 2 by something to get 7? No. Can I multiply negative 8 by something to get negative 7? No. And can I multiply negative 7 by something to get negative 2? No. Now, you can, but I'm going to have to multiply by a fraction, and I don't want to do that. So, since I can't multiply one of them by something, now I'm going to have to look and see, well, can I manipulate both of the equations so that I get opposite coefficients? And you can, because, for example, I could multiply this by 8 and this by negative 7, and I would get opposites. Okay? Now, I don't want to deal with numbers that large, so I want to look at the variable that has the smallest coefficients. That is going to be the one I'm going to manipulate. So I'm going to choose to manipulate y. So I know that the least common multiple of 2 and 7 is 14. So I'm going to multiply by 7. I'm actually going to multiply by negative 7. No, we're going to actually multiply. It doesn't matter which one you do, but one of these, because they're both negative, I'm going to want to multiply one by a negative and one by a positive, and that way they're opposites. So I'm going to multiply this one by 7, and I'm going to multiply this one by negative 2. So I'm going to write my new equations in red. So 7 times negative 7 is negative 49x. That's minus 14y. And then 9 times 7 is, sorry, 9 times 7 is going to be 63. The next one, you have negative 2 times negative 8 is positive 16x. Negative 2 times negative 7 is going to be positive 14y equals negative 2 times negative 15 is going to be negative 30. Hold on just a second, I need to grab a drink. Alright, sorry about that. So, Now you're going to add, just like we did on the last one. Because now I have, so this is the new part. This is the new part that we have to do. This right here that I have in red is now exactly like what we started with. Oh, and I missed one. So now it's exactly like what we started with here. Okay? So I'm going to add these together. Negative 49 and positive 16, that's going to be negative 33x. These will give me 0 equals 63 and negative 3 is going to be positive 33. I'm now going to solve for x. So I'm going to divide by negative 33 and I get x equals negative 1. Okay? And then again now, we are going to go ahead and we're going to find the value of y now. So now when I find y, I don't need to plug it into these equations here. I can actually plug it into my original equation. So I'm going to say negative 7 times x is negative 1 minus 2y equals 9. If you guys remember when we did the warm-up questions and I showed you that those two equations in the second warm-up question were the same equation, and I said that this was called a scalar, that's all we're doing here is we're multiplying these by a scalar. Okay? So this is going to be 7 minus 2y equals 9. And now I'm going to solve for y. So I'm going to subtract 7. I get negative 2y equals 2. Divide by negative 2. And I get that y equals negative 1. And then we could check our answer again, which I advise that you do. And we'll find out that our answer is negative 1, negative 1. Okay? Now, that actually happened to be example number 3. So now we're going to go back and we're going to do example number 2. So again, we're going to start this problem the same way. We're going to look and we're going to see, does either of my variables, are the coefficients opposites? Well, right now you have x and 2x. So those aren't opposites. 7y and 14y. So those aren't opposites. And then you have 6 and you have 10. All right? So they're not opposites. Now you got to ask yourself, can I multiply one of the equations by a number to get an opposite coefficient? So if I was to multiply 1 times negative 2, I would get negative 2, which would be the opposite of this. So I'm going to go ahead and I'm going to manipulate the first equation by negative 2. This is going to give me negative 2x minus 14y equals negative 12. Okay, so in this one, I only had to multiply one of the equations by a number to be able to eliminate, because now I can go ahead and add. 2 and negative 2 is 0. Minus 14 and negative 14 is 0. 10 and negative 12 is negative 2. This gives me 0 equals negative 2. Now, if we go back to what we talked about previously, this is not a true statement. This is false. 0 does not equal negative 2. So this means that there are no solutions. Which, if we remember from the graphing, no solutions means that these two lines are parallel. Okay? Now, if we had been able to find a value for x here or y, whichever one, then we would have substituted it back in and we would have found the value for the other one, just like we did in example number 3. Okay? So, couple things. Make sure you do your steps. I want to see everybody put in a really good effort with their steps this weekend. Try your best. See what you can do. Some of it I've given to you, plain and simple. Some of it you're going to have to actually think about a little bit. So I want you to really try to do your steps, okay? Second, I want you to write down any questions that you have. Remember, I cannot answer your questions if I do not know that you have one. So write down any questions that you have. Anything you're confused about, you're concerned about, and we'll go from there on Monday. If I need to do another example in class, please ask me, okay? But I expect that when you come into class on Monday that you already have a good idea of what you're doing. Lastly, here are your 2 warm-up questions. I will have them on the board on Monday. I will be selecting people to do them. So I am asking you to try them now. All right? And that way, hopefully, you already have them done when you come into class on Monday. With that being said, other than that, have a great weekend. Remember, 90% completion from everybody in your class. I will give 20 extra credit points to the whole class. Okay? Anyways, other than that, guys, have a great night. Have a great weekend. And I will see you on Monday.